properties of exponents. The exponent rules. The exponent rules you need to learn and learn well. They will carry through geometry, algebra 2, the ACT, SAT, and beyond. It's important to understand that the base must be equal and learn how the exponents react to the operation. So the first operation is adding and subtracting. Well, to add and subtract, it's just combining like terms. We did that in step 3. When we add and subtract, we have to have exact variables with exact exponents match. And what we do with the numbers is we combine the numbers according to the operation. So, adding and subtracting. We don't change the common variables and exponents. They have to have the common variable and exponents in order to be combined in the first place. We can't add and subtract them unless they match exactly. So I'm going to leave x squared y alone. And I'm now going to look at the numbers at the positive 9 and the negative 10, which is negative 1. I write the negative and the 1 is invisible. I have negative x squared y. Subtract 6w from 8w. We're subtracting 6w from 8w. So we start with 8w, subtract 6w, we have 2w. The w is matched. I combine the numbers. 8 minus 6 equals 2. Adding and subtracting is not a new rule. This is combining like terms. The product rule. Product, as we know, means multiply. When we multiply, the rule is same base. Base of x will stay the same. And I'll add the exponents. So, in order to multiply, we must have the same base. In example 1, we have a base of h. And I'm going to add the exponents. 2 plus 6. So I have h to the 8th power. When we multiply number 2, we're going to multiply the numbers together. Negative 2 times 7 is negative 14. I have a common base of a times a, so I can multiply the a's together. And I'm going to add their exponents. 2 plus 3. I have a common base of b. That one has a 1 exponent that's invisible. The other one has an exponent of 1 that is also invisible. So I have base b, exponents of 1 plus 1. Simplified, I have negative 14 a to the 5th b squared. The power rule. Power means exponent. So we have an exponent raised to an exponent. Yep. So the base is x, and I'm going to multiply the exponent a times b. In example 1, I have a base of x, exponent 2 times 3, x to the 6th power. Following an order of operations, I need to simplify the exponent before multiplying by m cubed. So I'm going to bring the exponent in to the one term. So I have -2 squared m to the 5 times 2, all multiplied by m cubed. I still need to clean up this first term before multiplication. -2 squared is 4. And I have m to the 10th power times m to the 3rd power. Okay, now I have multiplication. I'm going to multiply the numbers together and add the exponents. 4 times 1 is 4. M to the 13th power. Quotient rule. Quotient means divide. The division rule for exponents is common base, subtract the exponent. Top exponent minus bottom exponent. Division. Divide the numbers first. Okay, 27 over 42 reduces to 9 over 14. I have a common base of x. I have a top exponent of 5 and a denominator exponent of 1. So I have 9 over 14 x to the 4th power. Had the exponent been negative, the term would go to the denominator of the fraction, which is why I kind of left it out here hanging in the middle until I did the subtraction and I knew whether to put the x term in the numerator or the denominator. Y squared raised to the 2nd power. Power raised to a power, I'm going to multiply the exponent. So I have y to the 4th divided by y to the 4th. Anything divided by itself is 0. Alright, negative exponent rule, as I just mentioned. So a negative exponent is a symbol for this term belongs in the denominator of the fraction. So x to the negative a is equivalent to 1 over x to the a power. Here we have the invisible fraction of x to the negative a power over 1. The negative exponent indicates that the term belongs across the fraction bar. So let's look at this example. -5, the number, there's nothing wrong with -5, that's just a number. The rule applies to negative exponents, not negative numbers. So x to the -2. We have a base x, and its exponent is -2. Therefore, x to the 2 power belongs in the denominator of the fraction. Placing it in the denominator corrects the power of the exponent. So it becomes positive once it's placed in the correct position. example 2. Take care of the numbers first. 4 divided by 8 will reduce to 1 over 2. We have a common base k. Powers 2 minus 5. 1 over 2. K to the negative third power. Therefore, when we write the fraction, we put k in the denominator with an exponent of 3. And the 0 exponent rule. If you can't remember this rule, just ask your calculator, want anything to the 0 power, any number or variable with a 0 exponent is equal to 1. It's like the great neutralizer. Any number to a 0 exponent is equal to 1. Any variable to a 0 exponent is equal to 1. Looking at example 1, we have we have 7 times x to the 0 power. The 7 is not raised to the 0 power. It's just 7 times x to the 0 power. And x to the 0 power is equal to 1. 7 times 1 is 7. Number 2, we've got to first simplify the numerator. We have a power rule, and the power rule is multiply the exponents. 4 times 2 is 8. So I have w to the 8th power divided by w to the 8th power. The quotient rule, when I divide, subtract the exponents. Minus 8 is 0. W to the 0 power is 1. And if you thought here, anything divided by itself is equal to 1, you were right. Alright, let's look at this practice. We're not going to cut and paste, we're just going to write the letter in of the equations under the correct column. So, looking at A, the division rule. 18 divided by 6, as we hopefully all know, is 3. That is correct. I'm going to use yellow for correct. And green for incorrect. When we find the errors. Alright, we've got a common base of x. We subtract the exponents. 5 minus 2 is 3. A is true. Let's look at B. Power raised to a power. 5 raised to the third power is 125. 125 is correct. Here I need to multiply. 2 times 3 is 6. X to the 6th power. B is also true. C. Power rule. X to the third raised to the third power. 3 times 3 is 9, not 6. D. I have a common base of 3, exponents of 2, 5 and 2. 3 raised to the 5 minus 2 would be equal to 3 to the third power, which is equal to 27, not 9. I shouldn't have been using green from the start, but it is false, so that will be more accurate. D is false. E. Multiplication product rule. We are going to add the exponent. 6 plus 6 is not 36. 6 plus 6 is 12. Quotient rule. 6 minus 3 is 3. Alright, we have, we need to simplify inside parentheses before raising it to the exponent of 0. We have x times x to the 5th times x squared. 1 plus 5 plus 2 is 8. Now, we multiply 8 times 0 and get 0. X to the 0 is equal to 1. G is true. Common base of x. 2 minus 4 is negative 2. This would be equal to 1 over x squared, not X squared. Two minus 2 is 0. That was tricky. That is equal to 1, not 0. That's a lesson in, even when it looks really easy, work it out. And J. And J. Don't let it intimidate you.